Glaciers are large masses of ice that rest quietly on the land, formed over many years from snow that fell and never melted away. Each winter, snow accumulates in places where the temperature stays cold enough that the snow from one season remains when the next season arrives. Layer after layer of snow piles up, and over time, the weight of the new snow presses down on the older snow beneath it. This pressure slowly changes the snow, squeezing out the air between the flakes and compacting it into something denser. The process is gradual and gentle, taking decades or even centuries. The snow crystals that fall as delicate, six-point shapes eventually become granular ice, and with more time and more pressure, this granular ice transforms into the solid, blue-tinted ice that makes up a glacier. The ice in a glacier is not like the ice you might find in a freezer. It has a different quality, a depth of color that comes from the way light moves through it. When light enters the ice absorbs the warmer colors, the reds and yellows, and allows the cooler blues to pass through or reflect back. This is why glacial ice often appears blue, especially in places where the ice is thick and dense. The blue is soft and tranquil, a color that seems to glow gently from within the ice itself. In some places, where the ice is very old and very compressed, the blue becomes deeper and richer, a color that feels almost timeless. Glaciers form in places where it is cold enough for snow to remain year-round. These places are often high in the mountains, where the air is thin and the temperatures stay below freezing even in summer. They can also form in polar regions, where the cold is persistent and the land is covered in ice for most of the year. In these environments, the snow that falls each winter adds to the snow that fell the winter before, and slowly, over many years, a glacier begins to take shape. The process requires patience, a slow accumulation that cannot be hurried. It is a process that unfolds in its own time, indifferent to the passing of seasons or the changes in the world around it. Once a glacier has formed, it begins to move. This movement is almost imperceptible, so slow that it is difficult to see even if you were to watch for hours or days. Glaciers move because of their own weight. The ice at the bottom of the glacier is under tremendous pressure from all the ice above it, and this pressure causes the ice to deform slightly, allowing it to flow like a very thick liquid. The movement is more like a slow creep than anything else, a gradual shifting that happens over months and years. Some glaciers move only a few inches per year, while others might move several feet per day, but even the fastest glaciers move in a way that feels unhurried and steady. The ice flows downhill, following the contours of the land beneath it, guided by gravity and the shape of the valley or basin where it rests. As a glacier moves, it carries with it rocks and sediment that it has picked up from the land. Some of these rocks are small pebbles, while others are massive boulders that weigh many tons. The glacier holds these rocks within its ice or drags them along its base, and as it moves, these rocks scrape against the bedrock beneath, slowly grinding it down. This grinding creates a fine powder called glacial flour, which is so fine that it feels almost like silt or clay. The flour is carried away by meltwater that flows from the glacier, and it gives the water a milky, turquoise color. Streams and rivers that flow from glacier often have this distinctive color, a sign of the slow grinding that is happening beneath the ice. The surface of a glacier is not smooth. It is marked by cracks and crevasses, lines that run across the ice where the glacier has bent or stretched as it moved over uneven ground. These cracks form because ice, while it can flow slowly, is also brittle and will fracture under tension. Crevasses can be shallow or very deep, some extending down through the ice for hundreds of feet. They are often hidden beneath a layer of fresh snow, creating a quiet and still landscape that conceals the complex structure beneath. The walls of a crevasse reveal the layered nature of the ice, showing bands of lighter and darker blue where different years of snowfall have been compressed together. In some places, glaciers are so large that they cover entire mountain ranges or vast stretches of land. These are called ice sheets or ice caps, and they contain an enormous amount of ice. The ice in these formations can be thousands of feet thick, a weight that presses down on the land beneath with incredible force. The land itself actually sinks under this weight, a process called isostatic depression, and it can take thousands of years for the land to slowly rebound once the ice is gone. The sheer scale of these ice masses is difficult to comprehend. They are so large that they create their own weather patterns, and the cold air that sits over them can influence the climate of surrounding regions. Smaller glaciers, found in mountain valleys, are called valley glacier or alpine glacier. These glaciers flow down from high peaks, following the path of least resistance as they move through the landscape. They carve out U-shaped valleys as they go, grinding away at the sides and bottom of the valley and creating smooth, rounded walls. After the glacier has retreated or melted away, the valley that remains has a distinctive shape, wider at the bottom and with steep sides that curve gently upward. These valleys are often filled with lakes or rivers, and they provide some of the most peaceful and dramatic landscapes on Earth. At the end of a glacier, where the ice reaches a point where it can no longer maintain itself, the glacier terminates. This terminus can be on land or in water. If the glacier ends on land, the ice melts slowly, releasing water that flows away in streams. If the glacier ends in a lake or ocean, large chunks of ice break off in a process called calving. These chunks, called icebergs, float away and drift with the currents. The calving process is quiet and gradual in some cases, with small pieces of ice breaking off and slipping into the water without much sound. The icebergs that form are pieces of the glacier, carried away to slowly melt in warmer waters. Glaciers are ancient. Some of the ice in the largest glacier fell as snow thousands of years ago, and it has been locked in the ice ever since. Air bubbles trapped in the ice contain tiny samples of the atmosphere from when that snow fell, creating a record of what the air was like in the distant past. Scientists can study these bubbles to learn about ancient climates, reading the ice like a book that tells the story of the Earth's history. The ice preserves this information in a way that is almost perfect, holding it in a frozen state until it is released by melting or uncovered by drilling. The weight of a glacier is immense. A single cubic meter of glacial ice weighs nearly a ton, and a large glacier can contain millions or billions of cubic meters of ice. This weight gives glaciers their power to shape the landscape. As they move, they pick up and carry enormous amounts of rock and soil, depositing it in new places when the ice melts. The piles of rock and sediment left behind by a glacier are called moraines, and they mark the places where the glacier once was. Lateral moraines form along the sides of a glacier, medial moraines form where two glaciers merge, and terminal moraines form at the furthest point the glacier reached. These features remain long after the glacier has retreated, quiet reminders of the ice that once covered the land. The sound of a glacier is subtle. There is the quiet drip of meltwater as it trickles from the ice, forming small streams that run along the surface or beneath the glacier. There is the occasional creak or groan as the ice shifts and adjusts, sounds that are deep and resonant, almost like the earth itself is speaking. Sometimes there is the soft crack of ice breaking, a sound that echoes briefly before fading into silence. These sounds are infrequent and gentle, part of the slow rhythm of the glacier's existence. Most of the time, a glacier is simply quiet, a massive presence that rests in stillness. Meltwater from glacier is some of the purest water on Earth. It has been frozen for so long that it contains very few impurities, and when it melts, it flows clear and cold. This water feeds rivers and lakes, providing fresh water to ecosystems and communities downstream. In some places, entire rivers are fed primarily by glacial meltwater, and the flow of these rivers changes with the seasons as the amount of melting increases in summer and decreases in winter. The water is so cold that it can be uncomfortable to touch, a reminder of its origin in the frozen heights above. Light behaves in interesting ways on and around glacier. The surface of the ice reflects sunlight, creating a bright, almost blinding glare on sunny days. This reflected light is intense, and it can make the surrounding landscape seem even more quiet and serene. Inside the ice, light is filtered and scattered, creating the soft blue glow that is characteristic of glacial ice. In caves that form within or beneath glacier, this blue light fills the space, creating an environment that feels otherworldly and peaceful. The ice glows softly, and the light seems to come from everywhere and nowhere at once. Snow that falls on a glacier each winter adds to the mass of the glacier, while melting in the summer removes ice. The balance between these two processes determines whether a glacier is growing or shrinking. If more snow falls than melts, the glacier will slowly advance, its terminus moving forward over time. If more ice melts than is replaced by new snow, the glacier will retreat, its terminus moving backward. This balance is delicate, and it can shift over years and decades, influenced by changes in temperature and snowfall. A glacier's size is never fixed. It is always in a state of slow adjustment, responding to the conditions around it. The temperature of glacial ice is cold, often well below freezing even in the summer. The interior of a glacier stays frozen year-round, insulated by the layers of ice above it. Only the surface and the edges of the glacier experience melting during warmer months, and even then, the amount of melting is limited. The cold is constant and pervasive, a fundamental part of what a glacier is. This cold creates an environment where time seems to slow down, where change happens so gradually that it is almost unnoticeable. Some glaciers flow into the ocean, and when they do, they create ice shelves, floating extensions of the glacier that rest on the water but remain connected to the land. These ice shelves can be enormous, covering thousands of square miles. They are thick slabs of ice that float on the ocean's surface, their undersides hidden beneath the water. Ice shelves move with the tides and ocean currents, and they are constantly being fed by the glacier behind them. At their outer edges, ice breaks off and drifts away as icebergs, continuing the slow process of redistributing the glacier's ice into the ocean. Glaciers exist in many parts of the world. They are found in Antarctica and Greenland, where the largest ice sheets cover the land. They are found in the mountains of Alaska, the Himalayas, the Alps, and the Andes, where smaller glaciers flow down from high peaks. They are found in Iceland, Patagonia, and Norway, in places where the climate is cold enough and the snowfall is plentiful enough to sustain them. Each of these glaciers is unique, shaped by the particular conditions of its environment, yet they all share the same fundamental characteristics. They are masses of ice that move slowly, shape the land, and persist over long periods of time. The bottom of a glacier is a place of darkness and pressure. The ice presses down with such force that the bedrock beneath is ground smooth, polished by the constant movement of the glacier above it. Meltwater flows beneath the glacier, creating a thin layer of water that acts as a lubricant, allowing the ice to slide more easily over the rock. This water is under pressure, squeezed between the ice and the bedrock, and it flows in channels or spreads out in thin sheets. The flow of this water is invisible from the surface, but it plays an important role in how the glacier moves. Glacier can create lakes in several ways. As a glacier retreats, it can leave behind depressions in the land that fill with meltwater, creating small, clear lakes. These are called kettle lakes, and they are often very deep and very cold. Glacier can also dam rivers, creating larger lakes that sit against the wall of ice. Sometimes these lakes drain suddenly if the ice dam breaks, but usually they drain slowly, feeding rivers downstream with a steady supply of cold, clear water. The lakes formed by glacier are some of the most pristine bodies of water on Earth, surrounded by landscapes that are still recovering from the presence of ice. Rocks that are carried by glacier can travel long distances. A boulder that is picked up by a glacier in one location might be deposited hundreds of miles away when the glacier finally melts. These rocks, called glacial erratics, are often very different from the bedrock where they are found, and they stand out as strange, out-of-place features in the landscape. They are evidence of the glacier's journey, proof that ice once covered areas that are now ice-free. Some erratics are enormous, the size of houses, and they sit alone in fields or forests, quiet remnants of the Ice Age. The pace of a glacier is the pace of nature at its most patient. There is no hurry in the way a glacier moves, no urgency in the way it shapes the land. Everything happens slowly, over timescales that extend far beyond a human lifetime. A glacier might take 1,000 years to advance a mile, and then another 1,000 years to retreat that same distance. This slowness is part of what makes glaciers so calming to contemplate. They are a reminder that not everything in nature is fast or dramatic. Some things simply are, existing in their own time, following their own rhythm. The air near a glacier is cold and crisp. Even on a warm day, the air carries a chill that comes from the ice. This cold air flows down from the glacier like a gentle breeze, creating a microclimate in the valley below. Plants that grow near glacier are adapted to this cold, and they often grow low to the ground, forming mats or cushions that hug the earth. Mosses and lichens are common, their slow growth matching the pace of the glacier itself. These plants colonize the rocks and soil left behind by the glacier, slowly building up the soil and preparing the ground for other species to follow. Glaciers are patient sculptors. They shape the land slowly, grinding away rock and soil, smoothing rough edges and carving out valleys. The features they create, U-shaped valleys, hanging valleys, cirques, fjords, are some of the most beautiful and distinctive landscapes on Earth. These features remain long after the glacier has gone, permanent changes to the land that tell the story of the ice that once covered it. The smoothness of the rock, the roundness of the valleys, the depth of the fjords, all of these are the work of ice moving slowly over stone. In polar regions, glaciers are part of vast ice sheets that cover the land as far as the eye can see. These ice sheets are so large that they are difficult to comprehend. The ice extends to the horizon in every direction, a white expanse broken only by the occasional ridge or crevasse. The surface is mostly flat, with gentle undulations that mark the flow of the ice beneath. The wind blows across the ice, picking up loose snow and creating a fine, powdery drift. The sky is often pale, a washed-out blue or gray that blends with the ice, creating a landscape that feels infinite and unchanging. Ice cores drilled from Glacier provide a detailed record of the Earth's climate over thousands of years. Each layer of ice represents a year of snowfall, and by counting these layers, scientists can determine the age of the ice. The ice contains tiny air bubbles, dust particles, and other materials that were present in the atmosphere when the snow fell. By analyzing these materials, scientists can learn about past temperatures, atmospheric composition, and even volcanic eruptions that occurred long ago. The ice is a time capsule, preserving information in a frozen state, and studying it is like reading a book written by the Earth itself. Some glaciers have distinct bands or layers visible on their surface, created by differences in the ice. These bands can be caused by variations in the amount of dust or debris in the ice, or by differences in the density of the ice itself. They create patterns on the glacier's surface, lines that flow and curve as the ice moves. These patterns are subtle and beautiful, a visual reminder of the glacier's layered history and the long process of accumulation and compression that created it. The ice in a glacier is not static. Even though it appears solid and unchanging, the ice is constantly moving, flowing downhill under its own weight. This movement is so slow that it cannot be seen with the naked eye, but it is always happening. The ice deforms and flows, adjusting to the pressure from above and the shape of the land beneath. This flow is what allows Glacier to shape the landscape, to carry rocks and sediment, and to eventually reach a point where they melt and release their water. Glaciers store a significant amount of the Earth's fresh water. The ice locked up in glacier and ice sheets represents a vast reservoir, a reserve of water that is frozen and unavailable for immediate use. If all the glacier in the world were to melt, the amount of water released would be enormous, enough to raise sea levels significantly. But glacier melts slowly, releasing their water gradually over time, feeding rivers and lakes, and sustaining ecosystems that depend on this steady supply of cold, fresh water. The color of glacial meltwater is distinctive. It often has a milky, turquoise appearance, caused by the fine particles of rock flour suspended in the water. These particles are so fine that they remain suspended in the water rather than settling out, giving the water a cloudy, opaque quality. The color is beautiful, a pale blue-green that is unlike the color of water from other sources. This glacial milk, as it is sometimes called, is a direct result of the grinding action of the glacier on the bedrock beneath it. Glaciers create their own ecosystems. The ice itself is a habitat, with microorganisms living on and within it. These organisms are specially adapted to the cold, able to survive in environments that would be lethal to most other forms of life. Algae can grow on the surface of glacier, giving the ice a pink or red tint in some areas. These algae photosynthesize during the brief summer months, taking advantage of the sunlight and the thin film of meltwater on the ice surface. They are part of a simple but functioning ecosystem, one of the few forms of life that can exist directly on the ice. The snow that falls on a glacier each year is often very dry, with low moisture content. This dry snow is light and fluffy, and it piles up in deep layers. Over time, as more snow falls and the layers are compressed, the snow becomes denser and heavier. The transformation from snow to ice is gradual, with intermediate stages where the snow is neither fully snow nor fully ice. This intermediate material, called fin, has a granular texture and is partially compacted. It takes many years for fin to become solid glacial ice, and this process is one of the fundamental steps in the formation of a glacier. Glaciers respond to the climate around them, but their response is slow. A change in temperature or snowfall might not affect the glacier noticeably for years or even decades. The glacier's size and shape are determined by conditions that prevailed over long periods, and it takes time for the glacier to adjust to new conditions. This slow response means that glaciers are not good indicators of short-term weather patterns, but they are excellent indicators of long-term climate trends. They integrate conditions over many years, smoothing out the variability and revealing the underlying patterns. The texture of glacial ice is dense and fine-grained. Unlike the ice you might find in a frozen pond, which can be cloudy and full of air bubbles, glacial ice is clear and compact. The compression of the snow over many years has squeezed out most of the air, leaving behind ice that is solid and heavy. When glacial ice melts, it melts slowly, and the water that is released is very cold. Drinking meltwater directly from a glacier is an experience of pure, clean water, so cold that it almost hurts to drink, a reminder of its origin in the frozen heights. In some mountain valleys, multiple glaciers flow from different peaks and merge together, creating larger glaciers. When two glaciers merge, the rocks and debris they are carrying along their edges come together to form a medial moraine, a dark line of rock running down the center of the combined glacier. These moraines mark the boundary between the two glaciers and show the path each one has taken. If several glaciers merge, the combined glacier can have multiple medial moraines, creating striped patterns on its surface that look almost like rivers of rock flowing alongside rivers of ice. The presence of a glacier can be felt in the landscape long after the ice is gone. The valleys are wider and more rounded than those carved by rivers. The rocks are smooth and polished, covered with scratches called striations that show the direction the ice moved. Boulders sit in places where no river could have carried them. Lakes fill depressions that the glacier scooped out of the bedrock. All of these features are evidence of the glacier's passage, signs that ice once dominated the landscape and shaped it into the form we see today. Glaciers are quiet giants. They are massive and powerful, yet they move in silence. There is no roar of activity, no constant noise. The sounds that do exist, the drip of water, the creak of ice, the occasional crack, are infrequent and soft. Most of the time, a glacier is simply still, a presence that rests on the land without disturbance. This quietness is part of what makes glaciers so calming to think about. They exist without fanfare, doing their slow work over centuries, indifferent to the noise and activity of the world beyond. Snow that falls on a glacier in winter often remains on the surface until summer. When the warmer weather arrives, some of this snow melts, but some of it remains, protected by the cold temperatures at higher elevations. The snow that does not melt becomes part of the glacier, adding to its mass. This process repeats year after year, each winter adding new snow, each summer removing some but not all of it. The net result, over many years, is the slow growth of the glacier, a gradual accumulation that eventually becomes a river of ice. The ice at the center of a glacier moves faster than the ice at the edges. This is because the ice at the edges is slowed by friction with the valley walls, while the ice in the center flows more freely. This difference in speed creates a pattern of flow, with the center of the glacier moving downhill more quickly while the edges lag behind. The result is that the surface of the glacier is not flat but slightly convex, bulging upward in the middle. This shape is subtle, but it is a direct result of the way the ice flows. Glacier can survive for thousands of years if conditions remain favorable. Some glaciers are very old, containing ice that fell as snow millennia ago. These ancient glaciers are windows into the past, holding information about climates and environments that existed long before recorded history. The ice itself is a form of archive, preserving samples of the atmosphere, particles of dust, and other materials from ancient times. Studying these glaciers is like studying history, but instead of reading documents, scientists read the ice, layer by layer. The blue color of glacial ice is one of its most striking features. This blue is not painted on or added, it is an inherent property of the ice itself, a result of how the ice interacts with light. When light enters the ice, the longer wavelengths, reds and yellows, are absorbed, while the shorter wavelengths, blues, are transmitted or reflected. The denser and purer the ice, the more pronounced this effect becomes. In thick sections of glacial ice, the blue can be deep and intense, a color that seems to glow with its own light. Glacial valleys are often home to rivers that flow from the glacier's terminus. These rivers are fed by meltwater, and they carry with them the glacial flour that gives them their distinctive color. The rivers are cold, even in summer, and they flow quickly, rushing down the valley toward lower elevations. The sound of these rivers is constant, a background noise that fills the valley. The water is clear but not transparent, clouded by the fine particles of rock suspended within it. These rivers are lifelines for the ecosystems downstream, providing water that supports plants, animals, and human communities. The terminus of a glacier is a place of transition, where ice becomes water. Here, the glacier releases the water it has held frozen for years or centuries. The meltwater trickles, drips, and flows away, beginning its journey through streams and rivers to eventually reach the ocean. The terminus is often marked by piles of rock and debris that the glacier has carried with it and deposited as it melted. These piles form ridges and mounds, creating a rough, uneven landscape that contrasts with the smooth ice above. Glaciers are part of the water cycle, just like rivers and clouds and rain. Water that falls as snow on a glacier is temporarily removed from the active part of the cycle, locked in ice for years or decades or longer. Eventually, that water is released through melting, and it flows back into the cycle, evaporating into the atmosphere or flowing into the ocean. This temporary storage of water in ice is an important part of how water moves around the planet, a slow buffer that moderates the flow of water through the system. The weight of ice in a glacier is distributed over the land beneath it, creating a steady, constant pressure. This pressure is immense, but it is also even and unchanging, a weight that sits on the land for centuries. The land beneath slowly adjusts to this weight, compressing and deforming under the load. When the glacier eventually melts and the weight is removed, the land begins to slowly rebound, rising back up over thousands of years. This process, called isostatic rebound, is still happening in places where glacier melted at the end of the last ice age. Glaciers have no awareness, no intention. They do not choose to move or shape the land. They simply do so as a consequence of their existence. The ice follows the laws of physics, flowing downhill, melting when temperatures rise, accumulating when snowfall is sufficient. There is no purpose to their movement, no goal they are trying to reach. They simply are, existing in the present moment, responding to the conditions around them in a way that is entirely natural and unhurried. The surface of a glacier can be rough or smooth, depending on conditions. In some areas, the ice is broken and fractured, creating a chaotic landscape of ice blocks and deep crevasses. In other areas, the surface is relatively smooth, marked only by gentle undulations or shallow cracks. Fresh snow can cover the surface, hiding the underlying ice and creating a uniform white expanse. In summer, when melting is more active, the snow melts away to reveal the blue ice beneath, and small streams of meltwater run across the surface, carving channels and forming pools. The interior of a glacier is cold and dark. Light does not penetrate far into the ice, and the temperature remains well below freezing year-round. Within this interior, the ice is under pressure from the weight above, and it deforms and flows in response. The movement is imperceptible, but it is constant, a slow plastic deformation that allows the ice to move as a coherent mass. The interior is a place of stillness, where nothing changes quickly, where time passes in slow motion. Ice caves can form within or beneath glacier, carved out by flowing meltwater. These caves are temporary features, their shapes and sizes changing as the glacier moves and melts. Inside an ice cave, the walls are smooth and glassy, formed by the melting and refreezing of ice. The light that enters the cave is filtered through the ice, creating a soft, blue glow that fills the space. The air inside is cold and still, and the only sound is the occasional drip of water. These caves are fragile and transient, existing for a time before they collapse or melt away, only to reform in new locations. Glaciers are found at high latitudes and high elevations, places where the temperature is cold enough for ice to persist. The Arctic and Antarctic regions are home to the largest glacier, vast ice sheets that cover entire continents. Mountain ranges in temperate and tropical latitudes also have glacier, though these are smaller and often found only at the highest elevations. The distribution of glacier is determined by temperature and snowfall, and they exist wherever these two conditions are met in the right balance. The snow that falls on a glacier in a given year can often be distinguished from the snow that fell in other years. Each layer of snow has slightly different characteristics, depending on the conditions when it fell. A warm, wet snowfall produces snow with larger crystals, while a cold, dry snowfall produces fine, powdery snow. Over time, as the snow is buried and compressed, these differences are preserved in the ice, creating distinct layers that can be seen in the walls of crevasses or in ice cores. These layers are like tree rings, each one representing a year of accumulation. The edges of a glacier, where the ice meets the valley walls, are often marked by lateral moraines, ridges of rock and debris that the glacier has pushed aside as it moved. These moraines run parallel to the glacier, marking its boundaries. They are composed of material that the glacier has scraped from the valley walls and carried along its sides. When the glacier retreats, the lateral moraines remain, standing as ridges on the valley floor, permanent features that mark where the glacier once was. Glaciers have been a part of the Earth's landscape for millions of years. During ice ages, glaciers were much more extensive than they are today, covering large portions of the continents. These ancient glaciers shaped the land in fundamental ways, carving out valleys, creating lakes, and depositing vast amounts of sediment. The landscapes we see today in many parts of the world were shaped by these Ice Age glaciers, even though the ice itself is long gone. The features they created remain, a lasting legacy of the ice that once covered the land. The pace at which a glacier moves can vary. Some glaciers move steadily, advancing or retreating at a relatively constant rate over long periods. Others experience surges, brief periods when the glacier moves much faster than usual. A surge can last for months or a few years, during which time the glacier advances rapidly before returning to its normal pace. The causes of surges are complex, often related to the buildup of meltwater beneath the glacier, which reduces friction and allows the ice to slide more easily. Even during a surge, though, the movement is still measured, still slow compared to the movement of water or wind. The meltwater that flows from a glacier is very pure. It has been frozen for so long that any impurities have been filtered out or are present in such low concentrations that they are negligible. This water is some of the cleanest on Earth, untouched by pollution and free from most contaminants. It is cold, almost painfully so, and it has a crisp, clean taste. This purity makes glacial meltwater valuable, both as a source of drinking water and as a resource for ecosystems that depend on clean, cold water. Glaciers exist in a state of slow equilibrium, constantly adjusting to the conditions around them. They gain mass through snowfall and lose mass through melting, and the balance between these two processes determines their size. This balance is never perfect. It fluctuates from year to year, season to season. Over long periods, these fluctuations average out, and the glacier maintains a relatively stable size. But if conditions change, if temperatures rise or snowfall decreases, the balance shifts and the glacier begins to shrink. If conditions become more favorable, cooler temperatures, more snow, the glacier begins to grow. This slow adjustment is always happening, a constant process of gaining and losing ice. The silence of a glacier is profound. In places where glaciers exist, far from roads and cities, the quiet is almost complete. There is no hum of machinery, no voices, no traffic. The only sounds are natural: the wind, the occasional call of a bird, the soft trickle of water. This silence is calming, a reminder of how quiet the world can be when human activity is absent. It is a silence that feels ancient, as if it has always been there, unchanging and eternal. The snow on a glacier's surface reflects sunlight intensely, creating a brightness that can be overwhelming. This reflected light is so strong that it can cause snow blindness if proper eye protection is not used. The brightness is pure and clean, a white that seems to glow. On overcast days, the light is softer, diffused by the clouds, and the glacier takes on a more muted appearance. The ice and snow blend with the gray sky, creating a landscape that is monochromatic and serene. Glaciers are patient. They do not hurry. They exist in a timescale that is far removed from the daily rhythms of human life. A glacier takes centuries to form and centuries to disappear. It moves so slowly that its progress is measured in feet per year or inches per day. This patience is part of what makes Glacier so fascinating and so calming to contemplate. They are a reminder that not everything in nature is urgent or fast. Some things simply take time, and there is a beauty in that slowness. The cold of a glacier is constant. Even in summer, when the air temperature might be mild, the ice remains frozen. The cold radiates from the glacier, creating a chill in the surrounding air. This cold is part of what defines a glacier, a fundamental characteristic that allows the ice to persist. It is a cold that feels ancient and deep, as if it has been there forever, unchanged by the passing of seasons. At night, a glacier rests in darkness. The sun sets, and the ice is bathed in shadow. The temperature drops even further, and the slow processes of melting and movement pause or slow down. The glacier becomes even quieter, if that is possible, a silent presence in the night. The stars shine above, and the ice reflects their light, a faint glow in the darkness. The night is still, and the glacier waits for the sun to rise again, patient and unchanging.